Hello everyone, welcome to Next One Coding. Today we're going to solve LeetCode 4025. Minimize the maximum waiting time at synchronized traffic lights. This is the second question which is asked in the weekly contest 515. So let's understand the problem, then we come up to the solution. The problem states that there are some traffic lights which have different green duration time, lights of I denoting the duration time of each light, but the traffic light have same cycle period. So the red duration of each light will be period minus lights of I. Now there are some cars which have the arrival time given in this arrival time array. Now we have to assign each car to a traffic light so that the maximum waiting time of any car will be minimized. Now suppose a car comes at time t and the value r with t modulo period. Okay. Now if we assign this car to a light which have the green duration of g. Now, if r is lesser than g, then the waiting time is 0 of this car. Else, the waiting time of this car will be period minus r. Okay. So now we need to minimize the maximum waiting time of any car. We need to return that. Okay. Now if the question is clear to you, now let's jump to the solution. So as you can see, we can assign any number of cars to a light. There is no restriction. And you can see that if our r is lesser than g, our waiting time will be 0. Else it will be period minus r. Now it will be pretty obvious that if we have the g which have the maximum value, then the possibility of getting waiting time 0 will be higher, right? That's why we will try to assign each car to the maximum g time with signal light. So we assign the signal light which have the maximum green time. We will assign all the cars to that signal. So the waiting time will be 0 for those cars which have r less than g, and which have more, which have the r greater than or equal to g, the waiting time will be this. So it is simple. So just we check the r for each car. For each car, we just do the r as our time of arrival modulo period, and we check if our r lesser than g, then we do nothing. Else, we just try to maximize our answer. So we need to minimize the maximum waiting time. That's why we need to do the max over here. And to get the g, we just need to find the maximum value in the lights array. So g will be nothing but the max element in our lights array. So I hope the solution is clear to you. Now I'll just quickly code it up. Okay, so there will be a ANS which will be 0. Now we need to calculate the g, which will be the max element. In the lights array. Now just iterate over the arrival time. Now calculate the r. Now if r is lesser than or just r is greater than equal to g, then we just do the ns equal to max of ns comma period minus r. Right? Now just return our ns. That is done. Now quickly run it up. It is running fine. Submit it. It is accepted. So the time complexity of this approach would be big of n. We just running over this light array and arrival array, and the space complexity would be big of 1. We are not using any extra space. That's why big of 1. So I hope this solution is clear to you. If you have any doubt, you can comment me out, and please do like, share, and subscribe. Thank you.